So for our next speaker, we have, well, he's a little bit taller than Martin, but no, this gentleman, a couple years back when we were hosting ControlsCon, I says, you know, we couldn't get the president. I says, well, I want your most technical digital person. And I'm like, and so they introduced me to Tom. And Tom, for those of you who are familiar with Belimo, which I think most of you are, where is Tom? There he is. Okay, come on up, Tom. So a lot of you, so Belimo is on a huge run with the data centers, for those of you who don't know. I mean, they have gotten into the design of the data center at a huge scale, and we're seeing all this business from it. Well, the crazy thing about it is and Tom will talk about, a lot of it's because of the digital work of their valves, and so it's kind of cool how the whole thing has come full circle. So
it is,
and I'm so happy. I'm so happy to have Tom up here to tell us about that journey, where we are, where we're headed. So Tom Daenzer from Belimo, thank you for being up here. Go get him.
This is forward right here. All right, thank you. Thanks, Scott, and thanks to the whole Cochrane Supply team for hosting this wonderful event and giving me an opportunity to represent Belimo in front of you guys. As the slide says, normally when I talk at a conference, people tell me what they want to hear. It's always, what's next with Belimo? So, but as we heard earlier, the world's a little crazy and things are happening fast, so it's more of a what's now kind of presentation than a what's next. For those who don't know me, I'm an ex-system integrator. I was one of you guys, and I've been with Belimo for about 15 years now. As Scott said, my focus has always been digital. I represent the Americas market from understanding what you guys need and building that into our innovation stream. So find me if you have any questions or feedback on kind of digital topics over the next couple days, and we can have a good conversation. T-shirt is a prop from the Great Outdoors movie, if you don't recognize it. I'm from Minnesota, so this spoke to me. Plus, it's nice to wear a T-shirt instead of a dress shirt when you're presenting. So with that said, how many people here were at Control? I know this is a while ago, but 3 years ago, as Scott mentioned, I spoke at ControlsCon in beautiful downtown Detroit. How many people were there? Okay, so I only have to apologize to a small portion of you. I'm gonna start with a little recap of what I talked about then, and then move forward. So this was a big. In the game. Anyone remember this?
Steve Eiserman.
There you go, Eiserman with the deep. So this is when I started in the controls industry. So 30 years ago, things were a little jagged, but still fun. And then we fast forwarded to about 30 years later, games look a little bit different. This is what the gaming industry did with all of this traditional computing power that was available to them. In 2023, we had about 100,000 times the processing performance in a gaming machine that cost about the same as the one from 1994. So just a little quick intro. And then the reason for this was technology was accelerating, the hardware technology was accelerating a very rapid pace. So this is a nice hockey stick chart of what technology you could get in terms of data storage per dollar. And this is what it looked like in 2023. And a weird thing happened, and this chart did not continue the way it was. And a lot of this is due to the bottlenecks of supply chain. Most of it's due to this big giant AI industry gobbling up all the components and raising prices. So that nice steady upward trajectory of more storage for your dollar has pretty much diminished. Same thing has happened with computing hardware. If you look at how much you get in terms of transistors per dollar in a processor, CPU, GPU, again, nice hockey stick pattern, that actually fell off, and actually you're getting less transistors, if you will, for your dollar. And again, this is driven by all of this giant AI expansion that's undergoing right now. And then finally, the other metric I referenced was connectivity. This has actually stayed fairly flat, maybe gone up a little bit. This is about how much you can get in terms of speed in your home internet for $1. And a lot of that has to do with, well, what you have now is actually good enough. People aren't actually innovating in that space, and there's not a whole lot of competition. So with that out of the way, basically what I'm saying is I was wrong if you were here 3 years ago. This trend didn't continue. And the premise of that conversation was that innovation is increasing at such a rapid rate that we're going to end up with everything will be digital. Every small device will have communications and smarts and sensing. And that was driven by this cost versus performance relationship. And it just hasn't happened. But that being said, things are still moving forward. Any Nuggets fans here?
Maybe a few.
Maybe a few. All right, well, this is what a video game today with AI would look like. I just wanted to show Rudy Gobert blocking Jokic. So amazing things can be done with the processing we have today. And just to throw a little facts and figures out there regarding AI, if you compare traditional computing with AI computing, for kind of a data-intensive task, it's about 100 times more efficient. So that's processing power per watt of power. And then if you look at how much better the training of AI models is going on an annual basis, it's roughly about 3 times better every year in terms of efficiency. The chips themselves, even though you pay more for them, for the number of transistors that's in them, they're actually going up significantly in their performance per dollar. So about a 37% increase in terms of gigaflops, so that's computing power per dollar. And then finally, when you prompt a LLM, that process, so there's two primary parts of AI. You train a model and then you prompt it for information. The prompting portion is about 40 times more efficient today than it was last year and the year before. So all in all, we still have even a better hockey stick pattern, which is basically saying that every 3 years we get 10 times the performance out of AI per dollar. And the metric is tokens per dollar. You've probably heard that. If you haven't, it's basically a metric that defines the input to an AI model, and the output is done in terms of tokens, how complicated it is. So AI is doing some pretty phenomenal things. Depending on where you stand, some people think it's scary, some think it's the best thing ever. It's a little bit of both, but I think it's maybe a call to action for our community to make sure we use AI to the best of its potential and make our buildings better. So last time I talked, I said, hey, we think we should have digital devices communicating all the way out to all our peripherals. So not just the controllers, but the actuators, the valves, and the sensors. And we've been working for the past few years to build out a whole new generation of products. We call it our new digital generation. It covers, like I said, valves, actuators, and sensors all on the same platform. So we released the first product from that platform called our GM late last year. Some key features that are consistent across this platform are you use an app to configure it via NFC. There are no dip switches, no reversing switches, no angular rotation limitation. That's all done digitally within the product. We have a better motor controller, a new ASIC, makes it more efficient. The gear train's almost silent now. They were quiet before, they're almost silent now. One of the coolest new things that hopefully you guys will be able to leverage is the new electrical interface. So in the past, we had almost every product came with a cable on it. And then in some cases, you could buy products with terminal blocks, but it only limited types of products. With this product line, you'll be able to buy anything with either a cable or a terminal block or a conduit connector. And they're actually field swappable versus what we have today. There's an LED display that gives you some kind of heads-up information about what's happening within the device. And then it's basically the same from a footprint standpoint. Now we're doing the same thing with our pressure sensors, is our first release for our sensor lineup. Again, you use the app to configure it. It comes in a wide variety of pressure sensor ranges. We even have a model that has 2 sensors in one, so you can do, let's say, fan pressure and filter sensor all in the same device. Same electrical interface, so ease of installation. Some pretty cool things we can do with a configurable LED display, even rotate it when you rotate the product. So innovative new products, but what I really want to talk about today is how they're the same, which makes us kind of modular in terms of expansion. So you'll notice that each one of those products, so I have a damper actuator, a valve actuator, and 2 types of sensors. They all have that same boxy orange footprint. And there's a reason for that, because if you take the cover off or you don't put the cover on, there's a common interface underneath there. It's the same physical, electrical, and logical interface for every product across the platform. So what that means is we can sell a basic product that does on-off control or modulating control, and you can use the app to configure that, change runtime, signals, things like that. But then we can also sell smarter products with communication by putting a module on top of those. And so let's say that module adds RS-45 communication and a couple sensors. That same module that we build can fit on every single one of those products. So it gives us fantastic agility in terms of adding new technology to the entire lineup of Belimo products. So what will we offer? Out of the gate, we plan an RS-45 module that'll be released beginning of next year, a PoE module. Again, these are products that in manufacturing will be welded onto the base product to enable you to have a smart communicating product. The last one that is on the near roadmap, which Martin talked about, is T1L. I think that's really going to change our industry. Every major control manufacturer I've talked to is either planning or has T1L in their lineup today. But that'll allow you to daisy chain devices and have them be IP and use existing cabling. So same ease of installation as a traditional MSTP product, but a lot of advantages over that. Okay, from a standard standpoint, we heard Ken talk about the scariness of protecting the systems we have, and if we truly want to build out a building automation system where all of the devices communicate, we need to secure it. And we believe BACnet Secure Connect, while it has its challenges and it's a lot of work, we really have to secure these networks if we're going to launch AI on them. So it's what we're planning on, it's what we're investing in. We hope everyone's doing the same. And then the other technologies that we think will drive the ability to put smart peripheral devices at a building, all connected via IP network, the first would be T1L, or single pair Ethernet. How many people are familiar with that technology? Okay. I bet if you ask next year, more hands will be raised. It's cool. I mean, it's 2 wires. It looks like BACnet MSTP or Modbus RTU cabling, 2 wires in, 2 wires out, and you can daisy chain devices, and you end up with a fast, secure IP network. So it's great for retrofit, and it's also great for new installation because you're not running Ethernet cables, standard Ethernet cables. You're not making home runs to switches and things like that. And then the other kind of foundational technology that we expect to have a big impact on our market, maybe not this year or next, but beyond, is Thread. Who's familiar with Thread? It's a wireless mesh technology. It's IPv6. It's kind of like a 6-low-pan network, so it's low power. You get a bunch of devices all working together, and they communicate. So I'm sure there are some people in the room who would say, I would never want to control a product via even an Ethernet connection. I want to use analog signals, or I really don't want to control a device like an actuator via a wireless signal. Our contention is that at some point, the data that sits inside of one of our products, whether it's an actuator or a sensor or a valve, Not just what feedback is it at, but maybe what's the temperature inside the device, or what's the torque profile look like, or what is the current power usage that the product is using. And getting all that information back to your AI-enabled building automation system, we think is going to do a lot more, create a lot more value from a product periodic maintenance standpoint, optimization standpoint. It's just a lot more data that can be made available. And we think Thread will be a big component there, because now you just power up a device and they all communicate and they all connect back to your head end. But you can always still control with analog signals, but use that wireless component to get the data out of the products. Okay, I promised Scott and I would talk a little bit about data center topics. This is, to me, a beautiful picture. It's like a mechanical room, and there's just a ton of beautiful orange devices, all in perfect alignment. We see a lot of these, and what this is this is a liquid cooling application for an AI data center, and these are everywhere. So who's sold energy valves into a liquid cooling application?
Well, we have, Tom.
Lucky you.
Not me personally, but our company.
So I'm talking to you, Scott. You want to come right here?
Sure.
So I just want to talk about this application a little bit, because it's really cool, and it was it's been a fun venture for Belimo to get out of the traditional HVAC space and actually get into that data center application. So you might wonder, what are all these things doing? Well, those 4 boxes, those are AI server racks. Okay, they're the ones doing the computing load, and they generate a lot of heat. Basically, they're like really, really, really expensive electric heaters. So you put power in, they compute, and that same amount of heat is generated. So they use liquid. So at this time, it's a liquid glycol mix, and you use that to remove the heat from the system. So those boxes make a lot of heat. The valves regulate the flow through those servers, and then all the water goes back to a CDU. A CDU is a cooling distribution unit. It's basically a heat pump, not a heat pump, it's a pump and a heat exchanger, and it ejects heat to a typical facility water system, so like dry coolers or a chilled water plant, something like that. And our valves are being used by standard in this application, and these things are going a little crazy. So what's our valve actually doing? It's just regulating the flow through this server rack. And so a typical today's generation server generates about 150 kilowatts of heat, and that valve needs to remove that by providing about 140 liters per minute. Martin, what's the conversion there? Is that like 45 or something like that? Yeah. Okay. Come on. You said you were. SI US conversion. Yeah. Anyway, sorry. What's unique about this application, you'd think that valve, it'd be great. It'll modulate to maintain it so that it's removing the right amount of heat. But the problem is those servers can go from 0 to 100 in like that. So they can be generating no heat, or they can be generating 150 kilowatts of heat. So the mechanical system, not just the valve, but also the CDU, the central plant, everything isn't fast enough to respond to that. So you're basically putting design flow on that server rack constantly. Okay, so that's the application today. One upgrade to that is pressure control. And again, this is getting into what it might look like to control flow across an air handler coil. But the idea here is these server racks have trays. There are 18 trays, server trays in these things, and they plug into a manifold, so there's supply water coming in and return water coming out. And the manifold, when you pull the tray out, there's disconnects, and they're leakless. You pull them out, and water doesn't flow through the tray anymore. And the problem is you remove too many trays, and you have a valve that's providing constant flow through that server. The velocity of the water is too high, and you end up eroding the channels in the cold plate. The cold plate is basically a block of metal that sits on the servers and pulls heat out of them. So instead of maintaining constant flow, you actually maintain a pressure drop across the server, and then when you pull racks out, well, the pressure goes up, the valve modulates down, and you end up with the right amount of flow through each server tray. So that's this really cool application that I hope some of you get a chance to have
Can I
some
interject
exposure
something?
to. Yeah.
So if any of you run into this, people at Belimo are there to support you in
Yes.
choosing your,
Yes.
could you just real quick explain that? Because this is really complicated for your valve takeoff. It's not as clear, the high pressure, the high flow. So Belimo helps you with the takeoff.
Yeah, sure.
Right, Tom?
We went from one person who was our data center team for quite a few years. I think we now have like 16 people in the Americas covering the data center business, and it just keeps growing. So it's been a fun ride. It's a completely different app. It's the same stuff, just a different application. So that's what I wanted to talk about today. Again, if you have anything.
I have a question.
Yes, sure, Scott.
Well, you can do that with the typical pressure independent valve. Why the smart valve?
Data.
Thank you.
Yeah, we have hyperscalers that are using our valve in a similar application to this for liquid cooling, and all they're doing is making it open or closed. An energy valve that all it does is it's either open or closed. It isolates. But they like the flow information, the glycol monitoring, the energy metering, the temperature monitoring, pressure monitoring, all of those things in one package. And that's what sells. That industry really loves packaged solutions. They don't want parts and pieces that someone has to assemble in the field. They want a box that just does its thing. And so Energy Valve's have been great there. That's my last slide. So thank you. Again, love to talk to any of you a little bit more about any of these topics.
Tom, thank you. That was awesome. Thank you. Well done.
Thank you.
Thanks, buddy. Yeah, the data center application, folks, is crazy. We're seeing it everywhere. And with the scale up going with the data centers, I think we should all be excited to see Belimo involved in all those designs. And it's going to be a fun ride for them. Their business is growing faster than most other businesses in the segment because of this. And I just want to reassert this data center concept in your head because they align themselves with the data center business. They change their business a little bit to make it work with what the data centers are asking for. But it's a good stomach lesson for everybody in this industry that wants to grow their business. The data center business is different than what we're used to, but we're still good at it. We just have to say yes. We have to kind of take some risks to go into it as an industry, and we're just at that point now. So I just want to encourage you all to think about that as you go forward in your day-to-day. So, Tom, do you want to add something?
Phone.
Oh, I thought you were going to add something to that, but that's...
You want me to?
Of course, please, yeah.
I wasn't thinking.
No, you weren't. I didn't think so. Tom, thank you again, Tom.